and connection. So today's webinar will cover NLPA KWA Standard 823, Preventative Maintenance, Repair, and In-situ Construction of Petroleum Sumps, and it's offered as part of NLPA's ongoing UST Inspector Training webinar series. The webinar will begin with EPA's perspective on the need for a code of practice regarding preventative maintenance, repair, and in-situ construction of petroleum sumps. Attendees will then hear from the chair of the Standard 823 committee regarding what the 2020 standard entails and how it addresses a number of subjects associated with petroleum sumps and UST systems. Finally, attendees will hear a contractor's perspective on how Standard 823 impacts work done at UST facilities. And now I'd like to introduce today's speakers. Russ Brauksieck is a professional engineer with the New York State Department of Environmental Conservation and is currently on assignment with EPA's Office of Underground Storage Tanks. Russ has been with the tanks program for over 35 years. Tony Rieck began work in the petroleum industry in 1978. He was the executive director of NLPA from 1988 through 1996 and is currently a technical standard advisor to the association. He formed his own company, TR Consulting, in 1991, and is chairperson of the NLPA KWA 823 Standard Committee. Finally, Ed Kubinsky is the Director of Regulatory Affairs, Training, and Certification with over 27 years of experience working for Crompco, a large UST testing service provider headquartered in Plymouth Meeting, Pennsylvania, servicing over half of the U.S. with their compliance testing services. He also serves as chairman of PEI's RP 1200 committee, is a member of PEI's Service Technician Training Committee, and member of the NLPA KWA Standard 823 Committee for Sump Repairs. Please join me in virtually extending a welcome to our fantastic panel. And with that, let's begin with today's first presenter. So I'm happy to introduce Russ Brauksieck with EPA's Office of Underground Storage Tanks.
All right, thanks, Drew. Appreciate NLPA putting on this webinar. Thanks for all you guys joining in today. We're going to be focusing on containment sump repair. So this webinar is actually building on the April 30th webinar that we did on spill bucket containment sump testing and repair. If you haven't seen that particular webinar, this is building on it, so I encourage you to go back and to get the webinar and take a look at it. It's available on the NLPA website. The main goal of that last webinar was to really get into when containment sumps had to be tested, who could do the sump tests, how the tests could be conducted, a little bit on compatibility, but to introduce the overview of the standard being drafted. We're building on that today, looking at the containment sump repair. As Drew mentioned, I'm going to start off taking a look at some requirements for containment sumps and moving into what about repairs of those sumps. Tony Rieck is going to come and really do a wonderful detailed job walking us through the standard itself, looking at a couple of key issues like what sumps can be repaired and what are those allowable methods that can be used. And Ed Kubinsky is really going to come in with some really wonderful examples of sumps that can be repaired, sumps that can't be repaired. And so we're really going to hopefully answer a lot of questions here. So as I said, I'm starting off with some requirements. So the first aspect of the requirements is when are containment sumps required? So everybody should be hopefully familiar. New dispensers, when they're installed, they have to have under dispenser containment. And if the owner operator is going to be using release detection in the form of interstitial monitoring, they're going to need to have a place to do the monitoring, and that's going to be typically the containment sump. So when we have sumps out in the field, what are owners and operators required to do with these sumps? Well, the one that we took a look at before was testing. And I really encourage, if you need more understanding of when sumps have to be tested, when they don't have to be tested, please go back and look at that webinar. But the other aspect that we didn't touch on before is all people that have these containment sumps are required to do walkthrough inspections. Those walkthrough inspections are for every operational containment sump. With one caveat, if there's an under-dispenser containment that has to be filled with pea gravel or somehow inaccessible for a visual inspection, those have to be electronically monitored for leaks. They really can't have a visual inspection. But the important thing is, as we're working with these containment sumps, they have to be repaired. When the sump fails a test, or they get out there and do an inspection, they take a look at it, and the inspection indicates a problem, there has to be a repair completed. Which brings us to today's session, really. So the repair of containment sumps is addressed in 280.33. So a couple of things that need to be aware of. One, prevent releases due to structural failure or corrosion. So it has to be a good repair. The second point is that it has to be properly conducted in accordance with a code of practice. Now, if you remember the other parts of the regulation, there's a lot of times where there's options presented. So it could be a code of practice, a manufacturer's instructions, something that the implementing agency allows. When it comes to repair, those are not options. What we're dealing with here is it has to be done in accordance with the code of practice. Second part to that is, well, up until now, there's really not been a code of practice for the repair of containment sumps. EPA got involved with NLPA and the other groups to try and come up with this standard. And so we're very happy that NLPA did a lot of great work to pull this standard together. Last point on the repair of containment sumps, it's not directly in 280.33, but things to keep in mind that whenever a sump is repaired, that repair has to be compatible with the substance stored, and there's going to be a need for records if it's going to be more than E10 or B20. Last part of the repair of containment sumps is looking at the aspect of when it gets done, there needs to be a test. Now, the test is required specifically for repairs of containment sumps used for interstitial monitoring of piping. But obviously, if a repair is done and it's needing to be repaired, it's a good idea to get it tested. With the test, this is something that the options are provided. So a manufacturer's instructions, the code of practice, or other requirements developed by the implementing agency. The code of practice has the standards in there for how it's to be tested, and we certainly encourage the use of that code of practice. Last but not least here, everybody should be aware the technical compendium is out there, and EPA did recognize the standard. We have a new section in the compendium dealing with repairs of US systems, and so that is explained in more detail at that point. So with that, that's the quick overview and taking a look at the regulatory framework for US repairs, in particular for containment sumps. So with that, I'll turn it back to Drew and any questions that might have come in.
Excellent. Thanks so much for getting us started here, Russ. Friendly reminder to everyone out there, at any time, feel free to send in your questions. You don't have to wait until the Q&A comes up. But we did get one already in, Russ. And again, feel free, audience, send them in as you think of them. And if we can't get to them now, we'll table them, hopefully time permitting, for later on. So the first and only question I have so far, Russ, the question is, how do you properly test and inspect containment sumps associated with field constructed tanks?
Can you repeat that one more time? Just I may need clarification from the person asking the question.
Sure, let me read how they wrote it. How do you properly test/inspect FCT containment sumps, as in field constructed tank containment sumps.
Okay, field constructed tank sumps. So that is certainly much larger question and something that I'm interested in, but the concept is pretty much the same. So with the testing practice in RP 1200 or here, the concept is you stress it with hydrostatic testing, but there's also other options available. And Tony's going to talk a little bit about those options as we get to the end of his presentation. So let me answer it to that degree now and table that for after Tony finishes his discussion about the standard itself.
Great idea. Thanks, Russ. Let's see here. As you get a few coming in. Let's see. So here's kind of a longer one. Bear with me, Russ. I'll read it off now. So question for you, Russ. And here is the question. It's got a preface and then a question. So here we go. We all know that repair materials have to be compatible with the substance stored. But what about decomposition products of the stored substance? And they say, for example, sumps and repair materials have to be compatible with ethanol, but what about acetic acid? And I can read that again if you like.
No, that's certainly a great question, and that is something that the NLPA standard addresses in the sense of there's a need to test for compatibility, but there's also the opportunity for the testing lab to look at additional things. So where certainly there's going to be exposure to byproducts of the regulated substance that's there, certainly that would be something that should be considered as the lab testing is done for the NLPA standard.
Great. Thanks, Russ. And thanks everyone for sending questions and just keeping an eye on time. I think we have time for just a couple more quick ones, so I'll put them out there and we'll table the rest of these for later. So feel free to send in more if you have them. So another long one, Russ. The question is, and it's got oh, sorry, I'm looking at the wrong one. Okay, here we go. The question is, how do you define a sump that can't be visually inspected? And there's a follow-up. Some UDCs have a smaller opening at the ground level, but a larger sump exists. Is that a non-inspectable UDC?
Well, that is a little more complex. So that's possible, and some of it's going to be site specifics and looking at particular situations. So walking through the normal annual walkthrough inspection, people are going to take a look at the sump visually and trying to determine if there's damage to that sump, particularly if that sump is involved with interstitial monitoring of piping. If it's a secondary containment of the pipe, there's a need to be able to be sure that that sump's going to be able to contain it. If there's not access to be able to make that determination of the condition of the sump, certainly one of the options would be to say it's really not accessible and require some electronic monitoring there so you know what's going on. But really, I think there's going to be a need to look at site specifics on that.
Great, thank you. I've got a few left, and I think we'll have to wait on a couple. I'm hoping they might get answered actually through the rest of the presentations. But I'll throw one more out there for you, Russ. I think we got time for it. So the question is, when a new dispenser is installed, are you required to also install UDC?
So, the regulatory requirement defines installing a new dispenser. So if it's a brand new dispenser, new line, new island, yes, it's required that there be under dispenser containment there. If it's a replacement sump, it has to be evaluated on how much of the equipment is replaced underneath that dispenser, it very well could trigger the need to have an under-dispenser containment.
Great, thank you. All right, well, I do have a couple more questions. I think we're going to hold on to those for now. And again, if they don't get addressed and we do have time later, we'll see if we can get those elevated to the panel or to Russ. So thanks for the questions, everyone, and thank you to Russ so much for presenting today and getting us started with your introduction. We really appreciate it. And with that, I'm happy to introduce our next speaker today, Tony Rieck with TR Consulting, and Tony is also the chair of the Standard Committee. So with that, I'm going to hand it off to Tony. Take it away when you are ready, sir. Screen looks good, Tony. You're on mute if you're speaking. And I'm gonna see if I can go ahead and unmute you, Tony. I think that might be the issue. All right, so I'm gonna unmute.
Okay. Hello, everyone. Thanks, Drew. NLPA KWA Standard 823 is the enhancement and replacement for the original NLPA KWA Recommended Practice 823. It is a first edition, still has that new standard smell. NLPA has been publishing standards since 1986. First standard that we published was NLPA Standard 631 on the inspection and repair and lining of underground storage tanks. A portion of that standard became an American national standard. Difference between our standard process and our recommended practice process is that the recommended practice is pretty much a how-to. The standard is a tool for measurement. In other words, it says what benchmarks a technology has to reach in order to be approved. Our standard process was refined in 1991 when we took chapters A and B of the NLPA 631 standard and applied the ANSI process. All of the standards from NLPA now conform to that ANSI process, whereas the recommended practices are simply a panel of people with knowledge who can provide information. A standard requires a balanced committee representing different interest groups. It requires a commentary period to address concerns of those who are not participating on the committee, and there has to be an appeals process for somebody who feels perhaps that their input was not properly considered by the standard committee. So the first thing we do is we find people who have a lot of knowledge, experts, and I have to thank them for this, they taught me an awful lot about sumps during this standard writing process. Me, I was pretty much just the traffic cop directing traffic through the intersection. But I had some very knowledgeable people that I was working with, Russ, for example, and Ed, who you'll hear from later, who had wonderful input as to what we needed to do in order to make a standard that was going to work. So different backgrounds, different views. You know, a manufacturer knows about their product. They know what its capabilities are, and they know how their products are supposed to be used. Contractors know the reality of the installation process and what actually happens in the field, which isn't always the way it was drawn up on the chalkboard. Owners know what they need, and regulators know what rules require and what can be enforced. So we had a balanced committee. You know, we had experts from each of these groups, and we had them in approximately equal numbers. The standard committee was comprised of 4 manufacturers, 3 contractors, 3 tank owners, 3 regulators, and me. But, I only got a vote if there was a tie, and since there were 13 other people, there weren't very many of those. In fact, almost everything that went through the committee was unanimous or near unanimous. Participation. Well, you can only have so many people on a committee before it becomes convoluted. But you need those outside people with various backgrounds and various perspectives to be able to also comment and contribute to the standards process. Their thoughts and needs are no less important than those who are directly represented on the committee. So NLPA standards have a 60-day public commentary period following the committee's development of a final draft. This time, there were not a lot of comments, so I have to say, good job to the committee. We didn't make the standard without having things try to present themselves in the way. COVID-19 was one of those challenges. Everything changed. The standards process didn't change, but everything affecting how we got
Tony, this is Drew. I think we might have lost your audio there. Not hearing you if you're speaking. I'm still not hearing you, Tony. Not sure if it's me or. Yeah, I just got some comments from the audience. Sounds like folks aren't hearing you either. So maybe scroll over to the audio pane and see if you can troubleshoot it there. Oh, you there?
Yeah, I'm here. My audio pane. Okay,
you're good. We hear you. No, we hear you. We hear you. I'm sorry. I think it dropped for a bit on your last slide. So take it away. Sorry about that.
Okay. Well, so back to challenges affecting the committee. In order to be able to represent what goes on within the regulated community and the regulating community, we had to have people from different areas of the country because not all areas of the country are the same. And that gave more perspective. Well, one of the problems with having people from different areas of the country is when you want them to get together, most, if not all of them, have to travel to get there. And with social distancing and travel restrictions, even though we had a need to meet, we had a limited ability to do so. Changes to business models, from handshakes to elbow bumps, and from in-person meetings to meetings that were held virtually online. Travel restrictions. Some companies instituted travel bans. There were several companies represented on the panel where the committee member could not travel because they weren't allowed to. And even if you were allowed to travel, there weren't a lot of options. Everybody was avoiding travel to stay at home. I'll not forget looking down Concourse B in Atlanta and seeing nobody in early April. It was an entirely different experience traveling. And there weren't as many flights because there weren't very many people flying. To get from Denver to Jacksonville took 2 days because there were no connections which would actually get me there in one. So not a lot of people flying, risks of mandatory quarantines, limited food options while traveling. That just really meant that there weren't going to be the same meetings that could otherwise occur. So the meetings had to change. And we have people that were working from home. We had people that were on different platforms as far as the meetings. Every company seemed to have its own platform, and sometimes they weren't compatible with one another. And so meetings were different. And not all of the things that changed were compliant with the NLPA Standard Development Protocol. The NLPA Standard Development Procedure requires a minimum of 2 meetings. The first is an organizational meeting of the committee, and the second is a ratification meeting to consider comments and formally approve the standard. We did eventually get both of those meetings in. The first one wasn't so hard because it happened right before COVID became a major concern. And it's really important to understand how meetings help. Face-to-face, there's no substitute for being able to sit down with people and actually hash out issues. Many of the issues that we faced, we simply listed a group of them and started work on those, everybody commenting on them, putting them back together, putting them back out. It was a lot more work than if people were actually sitting in the same room and able to discuss the actual issues amongst the panelists. And, now, of course, barking dogs and crying children become something which, before was a distraction, but now is something that you have to accept as far as potentially being involved in your meeting. But the good news is the committee worked through all of these additional hurdles. I can't tell you how pleased I was with the effort that each and every one of the committee members put in. And whereas we did have 2 subcommittees under the full committee membership there, I have these people to thank. Joey Arn with Petroleum Containment, Brian DeLagey with Technology, Ed Kubinsky, who you're about to hear from, with Crompco, Micah Nelson with S. Bravo Systems, Alfred Reed with the Broward Environmental and Consumer Protection Division, John Seeger with Sheets Environmental Services, Jerry Templin with the Kroger Company and formerly with the state of Colorado, Russ Brauksieck with the U.S. EPA, Bill Hickman with the Colorado Division of Oil and Public Safety, Olita Martin with 7-Eleven, Paul Reber with Icon Containment Systems, Scott Sharp with Armor Shield of America, and Jimmy Spiros with Neumeyer Equipment Company. And I just could not have done the work with a less capable group. And they represented all areas of the country from the Northeast to Florida to California. And so we got a really good perspective all the way through. Well, my view of a standard is it's like a roadmap. It helps people get to where they need to be. The table of contents is a map of the standard. And here are the different things which were addressed, and I'm going to go into each of them individually. Introduction, scope, reference documents, terminology and definitions, which you find in just about every standard. Significance and use simply says how to use the standard. Permits, plans, testing for tightness, and final report. Material approvals, sump evaluation, training and certification of installers, general safety considerations, sump fittings, procedures common to all work, sump structural repair, in-situ sump construction, sump fitting installation, repair, replacement, or construction of sump lids, testing and return to service, sumps made from other materials of construction, and keywords, and then finally contact information for the association. So there were 4 methodologies addressed in the standard. One was sump structural damage repair with applicable structural adhesive bonders or patches. 2, repair or replacement of sump entry and test fittings. 3, field constructing a retrofit single wall or double wall sump without removal of the existing sump. And 4, repair or replacement of sump lid assemblies to address surface water intrusion. Our scope simply was the intent of the standard. The repairs to sumps need to be performed in conjunction with or independently from replacement of or repair sump fittings. In other words, you may have to replace sump fittings. You may not have to replace sump fittings. You may have to repair a crack or a hole from impact. That might not correspond with the sump fitting needing replacement. Sump penetration fittings may be installed or replaced independently or in conjunction, therefore, with other procedures contained in this standard. A watertight lid assembly was something that we wanted to talk about because one of the ways that water gets into the sump is through the top. And of course, in-situ sump manufacturing, which simply uses the existing sump as a mold for the fabrication of a new sump. Strength and flexibility. Well, the strength is in the language. You want to have language which is truly enforceable, using words such as will, must, and shall to make it easy for the standard to become adopted and enforced. Flexibility is also required because what exists today might not reflect what's available tomorrow. For example, when the recommended practice was written, there was no such thing as a repair fitting. So it's the intent of the standard to be used as a whole, but we do realize that in certain instances, the whole of the
Your audio dropped there again, Tony. We lost you at in certain instances, and then it cut off. I'll hang tight and hope that it comes back again, like last time, but we can't hear you right now. Still not hearing anything, Tony. Still not hearing you for right now. I'm not sure if there's something you did last time to fix that.
On there, I tried hitting the speaker button twice.
All right, we can hear you now.
Fabulous. Okay, so we realize that it's not always possible for a regulatory agency to adopt the entirety of a standard because it may not be fully applicable to their particular situation. So in section 1.4.2, we have that authorities having jurisdiction may limit the options available under this standard. The user of this standard is responsible for compliance with all regulations and requirements. Reference documents. Well, there are an awful lot of standards, recommended practices by places such as the American Petroleum Institute, PEI, Petroleum Equipment Institute, and others, ASTM, that address different parts of the application of underground storage tank compliance. And in order to not have to rewrite some of these standards, give, for example, PEI 1200, we reference those standards. The reference is intended to be to the most recent edition of that standard or recommended practice. However, like NFPA 30, sometimes it takes a while for the newest edition to actually appear within the state's adoption, and therefore we realize that you may be adopting previous versions that are not the most recent, and that's, again, part of the flexibility built into the standard. Terms and definitions. Well, we wanted to make sure that the definitions we were using for terms consistently used within the industry were the same as those for other groups that have standards and recommended practices out there. PEI, API, and NFPA, for example, we checked their definitions against our definitions to make sure that they were at least pretty doggone close, and if not exactly the same. Significance in use just simply says that the standard, what the standard provides and how it's to be used. So the standard provides testing and performance requirements for materials to be used to perform sealing of containment sumps. It provides testing and performance requirements for materials used to perform repairs. It provides minimum criteria for qualifying a containment sump for repair. And the standard provides test and performance requirements for materials used to perform the installation or replacement of a sump entry fitting, not only from a compatibility standpoint, but also from a standpoint of suitability for use. The standard provides the testing and performance requirements for materials used to perform the fabrication of that new single wall or double wall sump using the existing sump as a fabrication mold. And it provides minimum requirements for installer certification and training by the equipment or material manufacturer, which the manufacturers felt was really important, that they have designed these materials and this equipment to be used out in the field, but they want to make sure that it's installed properly so that it doesn't get a bad reputation. And of course, you know, you have to comply with all of the rules and regulations for the jurisdiction where you're performing the work. And part of that is to make sure that you have proper permits and that your plans are approved and that you're testing for tightness upon completion of the work in order to be able to assure the regulatory agency that the work was done appropriately. Material approvals. Well, like I said before, the standard requires all materials to be tested for compatibility, but also tested for suitability for use as to its performance in its intended utilization. Compatibility assurance is based upon laboratory testing and attestation by the manufacturer. Both are required under the standard. EPA regulations, as we'll see in a second here, allow for the manufacturer simply to attest that the material is compatible. The standard requires that the manufacturer base that attestation on independent third-party testing in order to make sure that there's a basis for that attestation. A material that is approved for one brand of polyethylene sump is, under the standard, deemed appropriate for all brands of polyethylene sumps. There are minute differences between different polyethylenes, but they're not significant from the standpoint of whether you can use a repair material or not. The same is to be said for fiberglass reinforced plastic sumps. FRP sumps can be an isophthalic polyester, or they could be an orthophthalic polyester, or they can be a terephthalic polyester, or they could even be made from a vinyl ester material. But all of those materials have one thing in common. They bond to one another. So here's a little bit about committee insight. The committee was very concerned that compatibility would be viewed as complete under the standard. In other words, just saying that it's compatible doesn't make it so. And so because owners and operators are required to use a UST system that is made or lined with materials that are compatible, and owners and operators must notify the implementing agency at least 30 days prior to switching to a regulated substance which contains a level of ethanol or biodiesel which is greater than 10% ethanol or 20% biodiesel, or any other regulated substance. It's important to make sure that the materials which are in the sump are going to be compatible with the fuels which are going to be potentially contained by that sump. And, there were different ways of demonstrating compatibility with the UST system. And one of those said that equipment or component manufacturer approval, the manufacturer's approval must be in writing, indicate an affirmative statement of compatibility, specify the range of biofuel blends the equipment is compatible with, or the component is compatible with, and be from the equipment or component manufacturer. So, that's just basically saying that the manufacturer can say, yeah, this is compatible. The standard, however, said that we want a little bit more than that. Wanted the manufacturer statement of compatibility to be based on third-party laboratory testing results. Now, of course, that doesn't have that nationally recognized in there because that's sort of limiting. This opens the door to the use of regional or local laboratories who have the equipment and the expertise in order to be able to make the determinations following test procedures as, for example, laid out by ASTM. So our agreed upon language was, the manufacturer shall attest in writing to the compatibility of the equipment, component, or material, including specific and stated range of biofuel blends based upon the results of testing performed by a qualified independent testing laboratory. Additionally, the committee agreed that compatibility assurance alone was not enough, that the testing had to determine that the material
Your audio dropped there again, Tony. This is Drew. Sorry to interrupt. We lost you at the materials, testing of the materials. So we'll hang tight and hope that it comes back. Still no audio. Still not hearing anything from you, Tony.
I'm not touching anything, so I don't.
We're hearing you now. I think it might somehow be your connection with your phone there, but thankfully it's coming back.
We are having power issues here, so it's been quite a bit. There is power drop every now and again because I can see the lights go off on my backup power. So that might be it. But the committee agreed that compatibility assurance was insufficient, that testing had to determine that the material or device is suitable for the intended purpose by, for example, testing adhesion characteristics. Sump evaluation. The question becomes, is it broken beyond repair? And fiberglass materials are very amenable to repairs. Unless you have something really strange happening with a fiberglass sump, you can almost always add more fiberglass and resin in order to be able to make a repair. There are exceptions. You have a fitting that's right up against the wall of the sump and, makes it so that you don't have access to the area to be able to repair it, for example. But polyethylene sump repairs were looked at differently. Polyethylene is defined in some sources as what we call a non-cementable material. Simply what that means is that you can't glue stuff to it. And so when the recommended practice was out there, there was a prohibition about repairing polyethylene sumps because there was no material known to be able to repair a crack or a hole in a polyethylene sump. Well, lo and behold, several different manufacturers have developed materials which can be used in order to fusion bond a polyethylene sump. And it's not the heat-treated polyethylene bond that the polyethylene industry utilizes, but rather a chemical process which melts the surface of the polyethylene sump and allows the repair material to mix with the polyethylene material and creates both a mechanical and a chemical bond. However, the committee did view the extent of viable repairs to polyethylene sumps as being more limited. Crack, for example, if you're using a structural bonder to put the crack together, if the crack is separated too far, then there's not the ability to be able to properly apply that structural bonder. The size of holes should be limited to, according to the information presented in the committee, the size of the patch material which is utilized. There are fiberglass patches which have been manufactured with these same materials which chemically fusion bond to the polyethylene sump in order to be able to bridge large holes. Now, there's also a difference between mechanical damage and manufactured damage. And one of the reasons that we allowed up to an 8-inch diameter hole to be repaired was because there are some polyethylene sumps which were manufactured with 8-inch openings, and the 8-inch opening did not actually represent something where the sump had failed, simply represented something where the sump had to be sealed. So the extent of allowable repair under the standard was a major topic of discussion, and it was one of the few actual public comments that we received where somebody stated that they thought that the size of the allowed repair was larger. Understand that the committee did reduce the size of the repair that the manufacturers stated that they could repair in the standard. And unanimously, the committee, in both the committee work, where it was a major area of discussion, and in response to the comment, agreed unanimously that the limits expressed in the standard were reflective of the repair capabilities available to the owner. Training and certification of installers. The standard requires that all persons who perform preventative maintenance, repair, or in-situ sump fabrication are properly trained in the application of the materials and the installation of the equipment. This is a common requirement across many areas of the underground storage tank industry. The manufacturer of the materials, device, or system is required to provide a written certification of training. And of course, we have general safety requirements. Every time I put on a safety class, I understand that the biggest concern of petroleum contractors is John Q. Public. How do we keep John Q. Public from driving their vehicle into an excavation? How do we get them to not flick cigarette butts into the sump we're working in? And some safety considerations aren't exactly possible to enforce. You can't legislate common sense. And while I said it's impossible to anticipate every safety need in a complex and varied workplace, the basic guidelines for safety, such as being able to provide barricades to separate the workplace from the public access, were included within the standard, along with things like lockout and tagout, traffic control, and personal protective equipment considerations. So sump fittings. Well, there's a lot of different types of sump fittings. And it wasn't until I was on this committee that I realized how many different types of sump fittings there were. Some penetrations, that seal piping or conduit that enter or leave the sump, or that seal between primary and secondary interstitial openings. There's encapsulating and replacement repair fittings. There's quite a few different solutions that have been developed in order to be able to meet the needs for sump repair. Here's what we call a split repair fitting. Split repair fittings allow for repair without disconnecting the piping. That means you don't have to have a separate contractor in there lots of the time in order to be able to take the piping apart so you can get a fitting on there. Split repair fittings can be entry fittings, test fittings, or even a combination of entry and test fittings. And here's an example of a split repair fitting that was provided to me by one of the manufacturers. I believe it was Icon. And here we have the existing sump, and you can see that at the top, the fitting appears to be in pretty bad condition. So it's removed, and you can see that the surface has been abraded, and then a fusion bonding chemical is used to apply the split repair fitting. Now, this is what we call an encapsulating fitting. This doesn't require the complete removal of the existing fitting. Of course, if there's a space that needs to be monitored, you need to make sure that that pathway remains open, and so partial removal of the fitting may be required. But this one simply is bigger than the existing fitting and fits right over it. Then you have split repair fittings, which are combination fittings. Here you've got a reducing fitting, and you've got the ability to monitor the space between the two different, in the interstitial space between the piping. And you have special situations, two conduits coming through an existing opening. And here you have specialized fittings which can be used to seal two different conduits coming through the same piping. So there's a lot of different situations out there, and like I said, there are an awful lot of different types of repair and replace.
We're having another audio issue here, Tony. Just wanted to let you know. Can't hear you. I'll let you know when you are audible again. Hopefully that works again. Yeah, hopefully that was just another power surge. So thanks everyone for bearing with us in the virtual world. Still not hearing you now, Tony, but I'll let you know when I do. Yeah, still not hearing you now. No audio for the moment. Fingers crossed it comes back. Still not hearing anything. And you're back. Go ahead.
I'm back. Fantastic. Well, here's an example of a split repair fitting. And it shows basically how the fitting works and how it's put back together. This split repair design starts with the center ring that goes around the pipe or conduit. The outer ring is applied over the center ring, and a band clamp is tightened around the assembly. And when it's done, it looks like this. The fitting is installed without disturbing the piping. It can be sized to fit large pipe or even small conduit. So a procedure is simply, a work practice. General procedures for the following kinds of work are provided. Work practices that are applicable to all work. In other words, it doesn't matter what you're doing with the sump, these practices apply. Practices applicable to fiberglass sump repair. Practices applicable to polyethylene sump repair. Practices applicable to in-situ sump construction. And work practices that are applicable to fitting installation. I talked about these specialized bonding materials. These aren't caulk. They aren't sealants. They are structural bonders. In other words, they themselves become solid materials, and they bond to the material that is supposed to be repaired. Different materials for different constructions of sumps. For example, here's a two-part system used for FRP sump repair. So you can get cracks in FRP sumps and areas of small damage. Those can be repaired using structural bonding materials. The bonding material becomes a hard surface which can bridge small holes. Larger repairs are performed using fiberglass cloth and resin, which is applied to the fiberglass sump laminate and bonds to it. In both cases, proper surface preparation is key to a successful repair. We're going to hear that over and over again because it's true with every material. It's like you can't apply a coating to something that hasn't been properly repaired and expect it to work well. It's like expecting that you have peeling paint on your windows and you're going to paint over it. That just simply means that your paint is adhering to paint chips which are disbonded and ready to fall off. And so, of course, those are different than the fusion materials, and you'll see that the title of this is polyfuse, that are used for polyethylene sumps. As I said, polyethylene is considered to be non-cementable, which means you can't glue stuff to it. But there are these chemicals which have been developed which will melt themselves into the surface of the polyethylene in order to be able to create the bond that's necessary to repair the polyethylene sumps. And then you have in-situ sump construction, and this is where you take a fiberglass and resin material and you follow the contours of the existing sump in order to be able to create a new sump within the old sump, which is not dependent upon the original sump structure. One advantage that I see to this is that there's no disposal of the old sump. Another is that you don't have to dig up the lot and close down the station. So sump fitting installation. Well, all materials used to seal, bond, and attach sump fittings need to meet the requirements of Section 6 of the standard. That's the material testing section, and it's applicable to almost every section of this standard, including that for alternative materials such as concrete or metallic sumps, which do exist out in the field. Equipment and devices installed as part of the repair shall be tested by a qualified independent testing laboratory and approved by the repair method manufacturer for their intended use. That just simply says that they can do what they're supposed to do. Not that they're compatible, but that they can do what they're supposed to do. They're also required to be tested to make sure that they are compatible. The installation work needs to be performed by a qualified contractor or installer who's properly trained in the installation procedure by the manufacturer of that sump fitting and in accordance with the procedure set forward by that manufacturer. So here's an example of a procedure. This is how this is supposed to do. It shows where you're supposed to put the adhesive materials and on each of the bonding pieces, and it shows the basic way that it's applied to the existing sump and piping. And when it's done, it looks like it belongs there. Watertight lids. Well, some of these lids have been tested by flooding after hurricanes. And it's sort of an interesting thing that you can now have sump lids that when the sump's underwater, water doesn't get to the inside of the sump. So where water can enter through a poorly fitted or a broken or deteriorated or even missing sump lid, you need to install a watertight lid to keep the water out of the sump. Most of the designs include revamping of the top of the sump in order to create a better sealing surface. Mechanical attachments compress the lid against the newly created sealing surface in this instance. Or you can have lids which become part of the sump. With the in-situ manufacturing of sumps, this lid system can be applied, and it becomes an integral part of the actual reconstructed or newly constructed sump. Prior to being returned to service, you want to make sure that the sump isn't capable or is capable of containing any product within it and won't allow water outside of the sump to get inside. The NLPA KWA standard provides two options for the sump and procedure for testing a watertight lid. A fully hydrostatic test is option number 1. The committee agreed that only a hydrostatic test where the water level is no less than 4 inches above the highest sump penetration or side assembly seam is appropriate for the testing of a repaired or in situ constructed sump prior to being returned to or placed in service. Option 2 simply says that there are other methods and may yet be even more methods which are developed which can detect a leak of substance through the sump wall. We have hydrostatic tests that everybody's familiar with and comfortable with, except for your airport authorities, for example, that don't like to have water anywhere near their tanks. And there's a company, I guess, that does dry sump testing now using a fog, and many states have approved that. And so we don't want to limit what the authority having jurisdiction has deemed to be no less protective of the environment. And we don't want to make it so that some new technology, which is a better widget than exists today, is prohibited. And so here, this shows the actual testing of a sump lid. A lot of sumps are buried in materials that don't allow for the water level to be held at a level above the top of the sump lid. So recognizing this, the standard committee thought that a large volume of water applied to the sump lid area over a period
Hey, Tony, this is Drew. Sorry to interrupt, but we lost your audio there again, so we'll hang tight and assume that it comes back. So can't hear you now. I'll let you know when I do. Thanks. Still no audio. Still no audio. Coming back soon. Still can't hear you.
a couple minutes ago, but that
was
was
right. You're good. We can hear you now.
I'm back.
I think you are. Take it away.
All right. So, testing the lid. Okay, not sumps are in the same types of backfill often as the tanks, and that includes things like pea gravel, crushed stone, that don't allow for the water level to be held for a period of time over the lid. Well, it's reasonable in the committee's view that pouring a large amount of water over the lid where you can't get the water level to remain over the lid is indicative as to whether the sump lid is effective in being able to keep water out, because water from surface runoff or storms is going to react in the same way. It's going to go away into the permeable backfill in the same way that the water is applied over the sump. So a large volume of water applied over the sump lid area for an extended period of time is deemed by the standard to be a proper test of the sump lid. Of course, not all sumps are made out of polyethylene or fiberglass, and some of these are called vaults. Others are called sumps. They have the same basic requirements. They do the same things. They require maintenance and repair on occasion. And again, the standard points to Section 6 for materials testing in order to be able to show that the material used in the repair is suitable for that repair and that it's compatible with the product which it might be exposed to. Metal UDC sumps are actually pretty common, and they can look pretty bad. but it is possible to be able to take something that looks as bad as the picture on the left and make it look as good as the picture on the right and function in the same fashion as a brand new sump installed underneath of a dispenser. In this case, the dispenser was removed, but in many instances, the dispenser does not even need to be removed in order to be able to perform this type of repair. And that gets us to my final slide here, which is simply, the information about how you get a hold of National Leak Prevention Association and Ken Wilcox Associates. National Leak Prevention Association, as I mentioned before, has been writing standards in the petroleum industry for, that's got to be better than 30 years. And Ken Wilcox Associates, I think, is familiar to everybody. They're the ones that provide the testing laboratory experience and background in order to be able to help, especially with our recommended practices, to develop a proper protocol for use of our technologies listed in recommended practices and standards. With that, I guess that means if anybody has any questions, I'm open to trying to answer them.
All right, great. Thank you. Thank you so much, Tony. We do have quite a few questions here, so let's see if we can get through some of these. And back to our audience, I don't know that we'll get to all of them now, but we'll see. We're making good time now, so maybe we'll have time for a larger panel discussion at the end. So please keep sending them in, and we'll get to them if and when we can. All right, so some of these are a little longer, Tony, so I'll try to read them as clearly as I can, and if you want a reread, just let me know, and I'll read it for you a second time, all right?
Will do.
All righty, great. So the first question, should you seek approval from the original manufacturer of the containment sump before performing work per NLPA 823? And the follow-up is, would not the original manufacturer know best how to repair the product?
Okay. Well, let's start with that there are a lot of sumps out there where the manufacturer no longer exists. Secondly, the requirement that the sump manufacturer authorize a repair is a limitation. The sump manufacturer, in most instances, wants to sell new sumps. So that creates a conflict. And third, as far as the 823 standard is concerned, one of the technologies is to use the existing sump to simply be a mold for the fabrication of a new sump, where the old sump has no further viability and therefore isn't part of the equation. So my thought on that is that having a requirement to consult the manufacturer of the sump prior to making repairs simply creates conflicts. It doesn't create solutions.
Thank you. All right, the next question. Right, for compatibility testing, why is purified distilled water used? And the person says, I would think you would want to use something closer to brackish or groundwater.
That's a good question. First of all, it's compatibility with water. There is additional testing which is done with a brackish material for testing, where that could potentially exist, and that's something that, believe it or not, if you're in Minnesota and they put a bunch of salt down to melt the snow, that means that with the melt from that snow, that runoff is going to have a salt component. But my recollection of the compatibility testing, and understand that this compatibility testing was modeled after that which was done by UL for underground fiberglass tanks and for 1746 steel tanks. And therefore, I believe it includes a salt component, a chloride component, as well as different pH testing. So I do believe that both get addressed in the immersion testing. It's just that they're done separately.
All right, great. Looking through here, a lot of questions, folks. Appreciate it. Keep them coming. Okay, the next question is, would you recommend the removal of sealants or adhesives like Brauksieck that were applied years ago to repair sump boots, even if it does not currently meet manufacturer specifications?
Okay. Could you run that by me one more time? Because I wasn't expecting to meet manufacturer specifications.
Sure. The question is, would you recommend the removal of sealants or adhesives like Brauksieck that were applied years ago to repair sump boots, even if it does not currently meet manufacturer specifications?
Okay. Well, I don't think that Brauksieck or some of these caulks that were used ever meet manufacturer specifications. Certainly, if you're performing a repair, you want to properly prepare the surface to receive that repair. And in most instances, these caulks are not something that repair materials bond well to. Some of them I've seen are silicone, or I've seen that stuff that they have the guy floating around in the glass boat, with his rubber thing that somebody sprayed on the sump. Those materials have to be removed if the sump is being repaired using a structural bonder or something of that sort.
Great, thank you. I think this one is a yes or no, but we'll see. So the question is, to confirm, this is the first and only code of practice to date for repairs of containment sumps. And I'm not sure if you got that question, Tony. I'm not hearing you, so maybe it's another mute issue that we'll hang tight for. So not hearing you right now, but it gives me a good chance to come through the questions. We'll wait for your audio. And thanks to our next speaker, Ed. Ed let me know that we can keep taking more questions, and we're making good time. So that's helpful to know. We'll wait for you to come back, Tony. Hearing you for now, and I'll come to these questions while we're waiting for you. We're making good time. So thanks everyone for your patience with the audio.
Well, I did sort of,
We hear you. We hear you now.
Okay.
Okay. So go ahead. Did you get the question? Yes. So the question is, to confirm, this is the first and only code of practice to date for repairs of containment sumps.
Okay. The second part of it is that it's the only one that exists right now. There was a previous version of this, as I mentioned, which was a recommended practice, which was pretty much a how-to use an existing sump as a mold for the fabrication of a new sump. But this standard incorporated that technology and added new technologies which didn't exist previously. And so I'd say it's the only, at least comprehensive, document which can be used to address sump repair.
Great, thank you. All right, the next one's a bit longer, so bear with me. The question is, if piping is not monitored interstitially because it's an older system and water regularly enters a sump, do you believe inspectors should require or recommend removal of water or repair of sump?
Well, absolutely, you need to remove the water. Repair the sump, certainly, when water is entering a sump, you want to do something to make it so that the water no longer enters it, and that's repair. So otherwise, you have an ongoing problem and an ongoing compliance risk. So, yeah, I guess my answer is yes.
Great, great, thanks. All right, coming through here, let's see. This person just points out kind of so the question is, or the statement is, I just bought this standard and it has a date of October 1 of this year, but the headers say it is a draft. Can you please, are you aware of that? Can you explain that?
Yes, that has been corrected. The first probably 5 days. That is, the header for the actual sections was different than the header for the that started at the table of contents. And so there were pages that had the draft 5 thereon, and that has been addressed. And draft 5 of the standard was not modified in any way. That was what went to the ratification meeting. So if you have the draft 5 on there, that's I don't know, maybe a limited edition collector's item.
All right. Well, lucky you, whoever asked that question. You've got the collector's edition. We're going to keep going here. We've got good time, making good time. So the question is sump lid testing always a requirement in all states and or as intended by EPA regulation and guidance?
Wow. Okay. Well, I can't speak for the states, and I can't speak for EPA. But I think if you're going to put a watertight lid on top of a sump because you have problem with water intrusion, you want somebody to test it and make sure it's going to work.
All right. The next one's a little longer, so I'll read this off. Bear with me. So So there are greater than 8 foot deep sumps. That's the scenario they're defining. And they're saying filling these sumps with water is a significant amount of pressure against the penetration fittings. It is much higher pressure than a 3 foot deep sump test. The question is, do the rubber penetration boot manufacturers have a high pressure limit?
That's a good question. And my understanding of the hydrostatic test is that it's supposed to extend a minimum of 4 inches above the highest penetration, which may not be as high as the top of the lid. But, some states do require that the entire volume of the sump be filled as part of a hydrostatic test. And certainly it would be a good thing to know whether that level of water column could cause damage to the sump fitting. I wouldn't believe so, but it's not something that I have a definitive answer for.
Thanks. All right, we'll keep them coming, folks. We're going to do Q&A for another 5 to 7 minutes here before our next speaker. So we're making good time. So if you're really sitting on one, I've got a couple more here, and you might be able to fit yours in too. So if you're sitting on one, please send it my way. If we don't get to it now, we'll hang on to it, maybe get to it later. So with what we have left here, here's one. Okay, so the question is, do the bonding sealants and adhesive sealants require the same tests and have the same pass-fail criteria?
Okay. Adhesive sealants are used in the attachment of the fittings to the sump walls. The sealants aren't used in the terms of the standard for the repair of, say, cracks or holes. A structural bonder is utilized. And so the question was, again, so I make sure that I answered all aspects of that now that I've sort of qualified it.
So the question is, do the bonding sealants and adhesive sealants require the same tests and have the same pass-fail criteria?
The compatibility testing would be similar, if not identical, and therefore the pass-fail criteria would be the same. The difference between an adhesion material is that it would have to be tested to make sure that it had in addition to compatibility, that it had proper adhesion characteristics. A pull-off test.
All right. This came up early. This came up earlier. I think it was on the tail end of Russ. So I actually not sure if it was Russ or for Tony, but I think it's applicable for you, Tony. So the question: what is an allowable repair timeline?
An allowable repair timeline?
Yes, that's the question.
Okay. Well, if they're asking how long it should take, you would hope that the repair could be conducted in a short period of time. Sometimes the materials, and this is material specific, require a specific cure time prior to being put back into use. Some of those may be 24 hours, some of those may be 1 hour. There are also repair fittings now which don't have any adhesive material associated with them, which can be put back in surface immediately, and others which can be applied underwater. So it would be a material-specific consideration as to how long it would be before the sump could be placed back in service.
Great, thank you. All right, so here's another. So the comment / question is: extremely deep sumps need testing of all telescoping height of the sump, or just the lower level 4 inches above the highest penetration? So I'm not hearing you, Tony. I'm thinking maybe we lost audio again. So I'll hang tight, and I'm happy to read that one again if you'd like me to when your audio comes back. So we'll hang tight. I think I'll do one more after this. So again, if anyone's sitting on one, feel free to keep sending them in. We're making good time. Maybe we'll get to it. So I'm going to hang tight for you, Tony, for your audio to come back. I can read this again when you're ready, and then we'll see if we have time for one more for now. Still no audio for now. Still not hearing any audio right now, Tony.
Well, like I said, I'm just,
Here we go. I hear you now. I hear you.
Right. So if you'd repeat the question.
Absolutely. Yeah, my pleasure. So I'll just read it word for word. Extremely deep sumps need testing of all telescoping height of the sump, or just the lower level 4 inches above the highest penetration?
That would be a question I think that the chairman of the PEI 1200 committee would probably answer more thoroughly. My understanding is that if allowed by the implementing agency, that the test only has to be a minimum of 4 inches above the highest penetration within the sump.
Okay, thanks. All right, and I think this might have been. Go ahead.
This is Ed. I'll expand on Tony's answer there as the chairman of the 1200 committee. That the RP 1200 states that the test has to be performed 4 inches above the highest penetration or sidewall seam. So if the containment sump is telescoping and there are several seams where the sump risers are installed, you would test 4 inches above the highest sidewall seam in that case. So if there's 3 seams in that very deep sump, you would fill the containment sump 4 inches above the highest seam in order to do the test.
That makes sense.
Great. Thanks so much, Ed and Tony. And yeah, folks out there asking questions, if you feel like you'd love to elevate it to the whole panel, I think that just shows we got a qualified group here that can all speak to these issues a little bit. So if I butchered your question earlier when I asked it, and that's for anyone, if you want to reframe it or resend it again, maybe we'll get to it in the panel discussion and hear from the entire panel. So appreciate you jumping in there, Ed. So let's see if we can get to just one more here before we switch to Ed, who was just speaking. So let's see. Okay, so I'll do one more for now. So the question, I think we hit on this earlier, but this is a slightly differently phrased question. So the question is, for the UL testing, are sumps tested with acetic acid? And then the follow-up is, if that is the case, the standard should also require that for repair materials.
Yeah, I don't believe that the UL testing actually tests for acetic acid, also known as ethanoic acid. I do believe that there's pH testing which is performed, and that pH is probably more important to plastic materials than the actual acid itself. Yeah, no, I mean, acetic acid is something that has become a bit of a problem, especially in diesel tanks. So, yeah, there is no specific statement within the UL testing which requires acetic acid testing. That's my recollection of it.
All right, thank you. Well, thank you for that answer, and thank you for presenting today, Tony. And you kind of ran you through the ringer there with all those questions. So I appreciate you being present and offering your answers. We really appreciate it. I know those that ask the questions appreciate it too. So with that, we'll hang tight and. Sorry.
I guess I just wasn't thorough enough.
No, we'll hang tight and maybe we'll bring Tony back up along with Russ for the panel discussion later. So again, thank you, Tony, so much.
Thank you.
All right. Well, with that, it's my pleasure to hand it off to today's final speaker. I'm happy to introduce Ed Kubinsky with Crompco.
All right, good afternoon, everybody in the Midwest and the East Coast, and late morning for those on the West Coast. Transitioning right now to sharing my screen. All right, I believe we're up and we're ready to go here. So my name's Ed Kubinsky with Crompco. We are a large UST compliance testing service provider, primarily on the East Coast and Midwest and down into Texas. We've been doing quite a bit of containment sump testing over the years, and with the implementation of the new regulations in many states, we're seeing some failing tests with these hydrostatic tests, and also part of the test is a visual inspection of these containment sumps. So while we have quite a few testing crews that are doing the containment sump testing, we have only a handful of crews that are actually the guys that are doing the repair work. We have a number of crews primarily based in the Mid-Atlantic area that do our containment sump repairs. Just to let you know, these technicians, we consider them the experts when it comes to repairs. We don't, tell them what repair products that they have to use when determining what types of repairs are needed. They're the trained and certified technicians. We allow them to make the determination on what the best product is to use in the course of repair. So, keep in mind there's a number of repair products out there. What I did to prepare for this presentation was went into our system and looked at a number of repairs that have been recently done and grabbed a bunch of before and after pictures of these repairs, and that's what I'm going to be, sharing with you today. I look at these guys as, these are our unsung heroes, who have to contort their bodies in strange configurations in order to work in these sumps, oftentimes hanging upside down for a number of hours in a under dispenser containment sump to make repairs, to get owners back into compliance and make these sumps liquid tight so that they can pass a test. So kudos to all the guys that are out there doing this work. It's a difficult job. Just try to imagine having to do that day in, day out, hanging upside down in the dispenser sump. So unlike a lot of my previous presentations, I'm not going to have a whole lot of words going on in my slides. I'm going to be sharing a lot of pictures of actual repair and sumps that couldn't be repaired, and talking a little bit about them. So with that, we'll get going. So the most likely sump repairs that are needed, it's pretty rare that we need to perform structural repairs to the containment sumps. It doesn't happen very often that we see large cracks and holes in sumps that are needed to be repaired. In talking with, our repair crews, well over 95% of the time, the most common cause of a sump test failure are the penetration boots and or the piping interstitial boots. And a lot of times these can be visually identified without actually performing a hydrostatic test. So here we're going to get into some of the repairs that we've recently seen in the past couple months. This is a fiberglass sump that was in need of repair. We had a little bit of a seam separation. We also had a large crack in this sump. So here you can see a large seam separation that needed to be repaired. And in this case, we actually had to have the fiberglass tank sump manufacturer come out and do the job. And we were the certified company and certified technicians on site that oversaw the repair. So you can see the guy in the sump here doing some of his prep work, sanding down the fiberglass sump in order to prepare to make his repair. You can see some of the picture or some of the pointing out, where the problems are in the sumps. And here you can see what the repair looked like afterward, a bunch of laying up of fiberglass material over that crack in order to make the repair. And as Tony stated in his preparation or in his presentation, that there is no limitation in the structural repairs of fiberglass sumps, because you can lay up a lot of this material and seal up cracks, holes in the sumps. Probably the more common repairs that we see are polyethylene sump repairs. As you all know, we need to make these sumps liquid tight when interstitial monitoring is being used as the primary form of release detection. We need to make these sumps liquid tight in order to do a test. And over time, these old penetration boots, they tend to rot and crack and fall apart. And when we come out to do a containment sump test, a lot of times this is what we see. And obviously, we need to make some repairs in order to properly test this containment sump, because as it states in RP 1200, you need to be able to seal off these sumps in order to do a hydrostatic test. So first thing in this case we need to get rid of all the old penetration fitting that's falling off. So we're going to have to get down there and peel it away, break it off, remove all the old materials in order to get access to the fitting itself, and use what we used here and what we most commonly used are these split repair fittings that Tony had mentioned in his presentation. And as you can see, this piping is nicely sealed now. The repair is done properly, and we can now run a hydrostatic test of this sump. It's what a good repair looks like when it's done, nice and clean. Here's a containment sump where I think there was a question about Bostik materials and all kind of materials being smeared over fittings in order to make these sumps liquid tight. Here we have a sump that failed that had all that type of material. We'll just see a couple of these pictures are a little bit blurry, but I wanted to show them because you'll see all the material that we pulled out of this sump, when we made this repair. So here you can see we pulled a bunch of that gooped on material off the sump, and this is what it looked like when we removed the old failed fitting, and all that gooped up material around the fitting in order to seal it over years and years. And now we're going to do a proper repair to this under dispenser containment sump. So you can see surface preparation is pretty important, getting as much of that old material off and sanding it down, putting on the split repair fitting, and properly sealing that fitting. Had to do a number of fittings inside this under dispenser containment sump. Fortunately, this is one of those that are rather shallow, so it wasn't terribly difficult to make the repair, but as you can see here, and oftentimes anytime we're doing under dispenser containment repairs, we do need to remove the dispenser in order to make this repair. And as you can see, there's quite a bit of piping here before the shear valve, so this dispenser sump will need to be tested periodically because it is being used for interstitial monitoring. That single wall steel piping that you see there is all part of the piping that needs release detection. So if you're doing interstitial monitoring, the way you would be doing interstitial monitoring on this under dispenser containment sump is by using the sump sensor that you could see that's off to the side here, off to the left. And that sensor is monitoring all of the single wall piping there in the dispenser doing your interstitial monitoring. Okay, we're going to move on to a polyethylene tank sump repair, and here we had a little separation of the sump from the STP riser flange, and we also had a little bit of separation from another piping fitting in the bottom of the sump. And here you can see some of that repair bonder being applied to seal up the crack and the hole in between the polyethylene sump and the riser coming off the tank. There's another photo of that with that repair bonder, and then this is the final repair, how it looks when everything was done. More polyethylene tank sump repairs. Here we see some conduit fittings that were in need of repair. Upon closer inspection, there was some separation, and what caused the failure here was the separation of the flange and the sump. So we had to go ahead and remove the old fitting, clean it up, and what we ended up doing is an encapsulation repair of these fittings in order to obtain passing results. Some more photos of the repair. As you can see, the fittings don't need to be perfectly in the center. A lot of times you can have fittings coming in on harder angles or not perfectly square, and you could still make these repairs with a lot of the penetration repair fittings that we have available to us out there. Here's some more sump repairs. Another penetration boot that cracked away, and here we have a piping interstitial boot that has ripped, and in order to do proper testing of this containment sump, we need to be able to isolate that interstitial space here. When we do our test, we don't want any water getting into any piping interstitial spaces when we're doing hydrostatic testing. So this repair, this test boot fitting needed to be replaced, as well as this penetration fitting here. You can see a couple more photos of the repair or the before photos. Here's what these our technicians that do a lot of these repairs. This is what your job looks like for 6 to 8 hours a day, hanging upside down with the dispenser skirt grinding into your chest while you're reaching 3-4 feet down trying to make repairs. So here's the post repair fittings, another encapsulation fitting. And here's a repair of that piping interstitial boot that had to be repaired. It was another split boot repair. where we took the old one off, put the split boot on, and now you have a new fitting where you'd be able to hydrostatically test the sump, and you'd also be able to perform an air test of that piping interstitial space if necessary. So now we're going to get into some really ugly photos that I've been able to find over the last several months of some unrepairable sumps. Here we have an under dispenser containment sump similar to what we've seen earlier. However, the cuff at the bottom of the sump here was so chewed away, we weren't able to get the new repair fitting to properly seal on there. What happened when we tightened up this boot, every time it kept popping off because we could not get a good seal here. So unfortunately, this dispenser sump, we had to tell the owner that we weren't able to make the repair, and this sump was going to need a replacement instead of just a fairly simple repair. As Tony mentioned in his presentation, a lot of times the piping comes into these sumps on extremely hard angles, so trying to get repair fittings on in this case is nearly impossible. So the determination in this case was, again, proper repairs weren't going to be able to be made, so replacement was going to be the best option. Here you'll see some polyethylene sumps which has multiple cracks and separations. And if you go into the standard, the 823 NLPA 823, it talks about the limitations of the high density polyethylene repairs when it comes to cracks and separations. So take a look at that if you're looking at making structural repairs so that limitations are not exceeded, when doing those types of repairs. Here we're having a lot of separation between the pipe and the containment sump wall. Oftentimes we have fittings that are butted up almost right up against the containment sump. Unfortunately, again, not every sump is capable of being repaired. Sometimes we have to tell owners that, things need to be replaced. It's unfortunate. We try to repair, whatever we can, but in some cases it's just not possible. Here we have, I don't know what's going on with some of these fiberglass sumps, but it appears that there were two parts to the sump, and then it started pulling away from one another, and somebody tried to repair it by putting a steel plate on there and tacking it to the fiberglass so it wouldn't separate anymore. We made the determination we're not going to be repairing this sump and taking on that liability. Some more ugly photos, and you look at enough work orders, you're going to see a lot of these, these sumps that unfortunately that are out there, and hopefully with the new regulations, they're going to be identified, and a lot of these things are going to be either repaired or replaced over the next several years. So here we can see no penetrations on conduit fittings, huge gap in piping that's coming into containment sumps, more sumps that are just unrepairable. Conduit fittings butted right up against the wall. We can't get a good seal on any types of fittings around these conduits when they're basically embedded in the wall of the sump. Here you can see some contractors decide to spray some type of foam around the outside and also on the inside of the interstitial space here. We felt, again, it's just not a repair that we're willing to take on. So like Tony mentioned, again, testing is an important part of the repair process after testing is being performed, or after repairs have been performed. If you're going to test according to the standard basically follows PEI's RP 1200, stating to test, if you're going to do a hydrostatic test 4 inches above the highest penetration or sidewall seam of the sump for a minimum of 1 hour with a loss of no greater than an eighth of an inch or greater would cause a failure of the sump. And just to refer back to PEI's RP 1200, the 2019 version, we felt it was a very important caveat to put in there that, with all the low-level testing that's going on now, under no circumstances should low-level hydrostatic sump testing be performed for newly installed containment sumps or for the initial testing of containment sumps that have recently been repaired. So if owners are asking contractors, to do low-level testing immediately following repairs, I highly doubt most AHJs would be allowing that, but we have that in the standard there to say that that's something that shouldn't be done, and it's also covered in, the NLPA KWA standard to test a minimum 4 inches above the highest penetration or sidewall seam. And like Tony suggested, if the authorities having jurisdiction allow for some of the alternative testing to be out there, such as the dry sump method or the vacuum testing methodologies that are listed on the National Workgroup website, if the AHJ allows it and they find that to be no less protective of the environment, those methodologies could also be employed for testing after repairs. With that, I'm going to conclude my presentation and willing to take any questions or concerns that you guys might have. Thanks for your time this afternoon.
All right, thank you so much, Ed, for presenting. We do have several questions here. So, Ed, I think they weren't all technically addressed to you. They did come in when you were speaking, and they're topical. So I'll assume they were for you. And by all means, if you want to bat it to the rest of the panel, I defer to you on that. But there are quite a few good ones. So let's see what we can do here. All right. So the first question, Ed, how do you visually assess the undersides of penetrations?
Well, if you can get in there, if you can get in the sump, if it's an STP sump or tank top sump, get in there, lean over and look at it as best you can. If not, I'd suggest using, intrinsically safe flashlight with mirrors, to do the best inspection that you can. I know a lot of times there was a question earlier, what about doing visual inspections of under dispenser containments, that are difficult to be inspected? Well, we do quite a few annual visual inspections for customers, and what we recommend is that our technicians take intrinsically safe lights, poke your head in as far as you can under the dispenser and manipulate a flashlight and a inspection mirror to do the best visual inspection that you can. I think it's well understood that you're not going to be able to get your head underneath the penetration fittings, but a lot of times you do have the availability of a telescoping mirror that you can use and flashlight to do the best inspection that you can.
Thank you. All right, moving right along. So the question is, if you leave a test boot on piping, does the Schrader valve need to be removed for product to flow back into the containment sump?
The answer to that is absolutely yes. If you're going to leave one of those interstitial test boots that you saw, yes, you do need to remove the Schrader valve in order to allow liquid to drain back to the sump. If you're using an open interstice for monitoring, I believe some AHJs do allow, if you have those Schrader valves in the containments, in the under dispenser containment sump, they may be able to be closed. Again, check with the authority having jurisdiction, but in my opinion, you can leave the Schrader valves on then, as long as you would have a sensor in that containment sump that is doing interstitial monitoring for you. Otherwise, you would either need to have jumper hoses to jumper the piping from one section to the next, or you'd have to leave them open in order for the piping to drain into the sump. But if it's a sump, if it's a STP sump back at the tank top, the Schrader valve would absolutely have to be removed in order for the liquid to drain back into that sump.
Great, thank you. All right, next one's a little long, so bear with me. So the question is, in northern climates, are there any concerns with filling the sumps with water and it migrating into the interstitial space of the piping and freezing, causing even more damage?
Yeah, absolutely. That is a concern. We always want to make sure whether you're in the northern climates, southern climates, doesn't matter where you're doing hydrostatic testing. You want to make sure you're taking all precautions necessary, to avoid allowing water to get into the interstitial space of the piping, because it can cause damage.
So the next question, has there been a weldable repair approved for plastic sumps?
The only one that I'm familiar with is the I-bond that Tony mentioned in his presentation. That's the only one that I'm familiar with that can be used to seal cracks in polyethylene sumps. I don't know if any of the other presenters have any other experience with any other repair materials that can bond.
Other panelists want to comment on that?
Yeah, that's the only one I'm familiar with as well.
I don't have any other information.
Thank you, gentlemen. All right, I'm running out of questions, but we have a few more minutes, so please send one in if you're sitting on one. All right, so this one is for the question is for any panel member as it's framed, but the question is, start with you, Ed. In draft 823, post-immersion testing by a third party checks for a loss of 50%. And they say 50% seems like a lot. Is this percentage typical for this type of testing?
This is Ed. I'm not terribly familiar with the product testing that needs to go on by the manufacturers. I would defer that question to the manufacturer, or I think Tony might be best to give that one a shot.
Want to read that again, Tony?
Yeah, the testing, the 50% threshold is done at an elevated testing temperature in order to simulate a longer period of actual immersion. And the 50% threshold is not standalone. It also has to have a trend which shows that the level of loss associated with the physical properties of the material is stabilizing. So, but the 50% criteria is the same as used by UL.
Great, thank you. All right, so the next question, bear with me. Okay, so with knowledge that there are numerous companies and products available for use, do we expect that manufacturers will provide training to all the technicians performing the repairs? And the follow-up is, would work need to halt if the technicians are not qualified?
Well, this is Ed. The manufacturers provide free training and certification to our technicians. I help facilitate that training. We make sure that a certified technician is on every job, and not only are the technicians manufacturer trained and certified. Certain states require state-issued licensing and certification required to do repairs. So you need to make sure that you're covered on both those ends. That if you're getting into the repair game, that number one, you're getting your manufacturer training and you're staying up on that. Typically, it's renewed every 2 years. The manufacturers do excellent online training. Again, it's free. You need to reach out to the manufacturers. I guess I shouldn't speak for all manufacturers. I don't know if all of them are free, but some of them are free. But also make sure that you are qualified by the implementing agency wherever you're doing work.
Great, thank you. All right, we're going to do one more, and I do see a lot came in last minute here, which is good. I don't think we'll get to them today, so I encourage everyone. You'll get follow-up information from me just for participating today. So if you wanted to elevate your question to a panelist or to the panel, contact me with your question afterwards, and I'll try to link you up with the right person who spoke today. So with that, I'm going to pull out one more here.
Drew, are you there?
Yes, yeah. Sorry, my audio is good. All right, so the final question we're going to go with today is for the AHJ. Sorry, let me start over. If the AHJ only required a low-level testing, would you recommend testing of the entire sump?
This is Ed. When it comes to repairs, I would absolutely, suggest testing, the entire containment sump, meaning 4 inches above the highest penetration or sidewall seam after any repair.
Yes, in fact, the standard states such. And there's a note in there that said that was the committee's feeling about post-repair testing.
So the low liquid level testing can be, done on the periodic testing, that's required for compliance purposes if the AHJ allows. But if that sump fails a test and a repair would need to be done after the repair, a standard hydrostatic test, let's call it, should be performed, where if you're doing hydrostatic, it would be 4 inches above the highest penetration or sidewall seam of that sump.
Thank you. And with that, we have come to the end of the webinar today. So I'd like to extend a huge thank you to Russ, Tony, and Ed for all the work you put into presenting today. We really appreciate it. Reminder to the audience, this webinar will be posted on NUI